Well, this is really tedious. I'm using these wire ends here. That's the male side. There's a female side, but most of the ones I have been thrown away. Oh no, here's a good one. And you crimp them in a special crimping thing like this. And you clamp it, and that's crimped. The wire gets crimped in one spot, and the insulation gets crimped in another spot, and they come out pretty okay. Here's some female crimped connections that I made earlier on. This wire was too stiff to be used in the harness, so I had to go to some other wire. And this is one of the male crimps that I made in one of my testing things. And I would tell you, I have thrown away a lot of the females. They're just really hard for me to see that I got them in the right spot, and I mess up. But at any rate, that was today, and we have the tender wired. The tender has every wire it needs connected and through the harness right here. And these are all real flimsy things that will sway and move, we think. So now that we have the tender done, we're going to be starting on the engine side, and those will be the male pins that will plug into these guys. I have my little map here of the tender side. On the right side, I have the two buck boost wires for the smoke, and I have the motor wires coming out of the motor controller that go right to the motor. On the left side, looking here, we have buck boost power going to the puff and chuff board, and then this is simply the chuff trigger. Now, I had a decision to make on the relay trigger, when to fire the relay and where does the signal come from. The signal wire is these two yellow wires, and that's from a motor source somewhere on here. And what I've decided to do is use some foam tape and stick it on top of these resistors. The foam tape will insulate them and hold it down enough for some testing. And I checked the height, and if I put it right there, it's going to be plenty of room. It's going to clear the roof and all that stuff. I may put it on foam tape, and then I may wrap it with a tie wrap just to hold it on here. You can see I have this volt regulator stuck with foam tape, but it's also wired in pretty tight, so that's going to hold it together. Oh, and that's for the fan, right? Okay. So this one is to be figured out. Now, from the engine side, I made a little diagram so you can understand what's going on with the engine. Here's the harness coming in left and right. This is the engine, so two of the wires come right out and go to the engine. Two of these wires come out and go right to the smoke power, right here, right there, smoke power. Over here, two of the wires go into the puff and chuff power, and other two go down here to the chuff trigger, which we know we talked about earlier. I'm probably going to go to the magnetic reed switch, and I was thinking about it a little while ago. I think if I just remove this switch and use those two screws to bolt in a piece of plastic, I can replace the switch with a piece of plastic that would have a hole in it to put this down in, and I could just kind of glue it in place. That way I can take it off with two screws if I want to and go back. The only bugger for that is there isn't any bugger because these wires stay connected to him. So chuff trigger just disappears. It's replaced with this guy, and it then goes wired into the harness at this point right there. So the puff and chuff gets its power, and this goes through that. Now the logic for the relay is up on top here, and there's the relay logic, and all it's going to do is going to go from up here. The yellow wires will go down one to each of the motor. The black and red will come just curl around and go right there. I'm so sorry. The yellow motors will go down, yellow wires will go down to the motor, right and left brush. Then the black and red wires will come over here and go to the relay sockets on the board. So they'll just go pop and pop. So that's all going to be very short wiring, no more extensions, cut those off. And then it's going to be stuck down with sticky tape right there. And that's all that does. It's a sensor that tells the relay the motor's running or not. If the motor's running, the relay triggers and it goes and does something differently than if the motor's not running, then it does something else. Okay. And then the smoke is a straight power, puff and chuff is straight power, and the trigger is just a straight, get my trigger inputs into me, please. So that's going to look nice and clean, right? All that's going to be gone. You can see the tender here is looking pretty darn good, right? The wires, these are real flimsy wires. They're not captured very hard. You can see I can move them around. I can move them around like this real easy, and I think they'll swivel enough with ease. We'll find out. If I need to make any changes, I'll make the changes. We'll see what it is. I don't know, and go from there. The motor we know works. The fan we know works. I haven't powered these up, but I did go through, the circuit testing to make sure, yeah, the circuits are correct, and I know where the circuits need to go once I get them plugged in. I'm now going to turn my attention to replacing all this menagerie with nice, clean wire, and then sockets that are kind of come down through a hole. I'm going to drill a hole or make a hole somewhere in here like this, right in here. There'll be a hole in this fireman's deck right there, and so the wires, there's the connector, right? So the wires are going to come out a little bit. There's the connector, there's the connector. The wires are going to come out a little bit like right here in air, and that's just going to go straight up, on one on each side, and then they'll split off and go where they need to go. Should be okay. I had a short day today, that's why I didn't get any more than this guy, but that's a lot of wires, and these connectors are making me blind, I'm telling you. You think you practice, you get it. Boy, I'll tell you, you can't practice when you can't see. That's just hard. But I'm confident. I think tomorrow we'll be able to wind it up. Got my clips and all that stuff, so we'll keep chugging away. Oh, and I got to take this off and put that wheel on. That's going to be kind of a big deal, but I'll probably do that first thing. That way I don't have to do anything else with the engine. I can just put it right back together and keep it together. Everything I change. Oh, I know. I could take that all this off. Then I can get that limit switch off a little easier. And then I can do a little quick. I'm hoping it's a quick design. I haven't really thought much about it, but I'm guessing. Let's see, if we have those two holes like this, and that's bracket, it's going to look like that, and that's going to bolt down, and then might have to have a little relief and come over here, and then it's going to have sort of an oval is what I'm thinking, something like that. So it's going to have an oval like that, and I'll make sure it's the right size, and then this just screws in and this thing just slides down. And it's going to slide down right over that. So I'll make this long enough so that the center is here, and that the magnet would slide by like that. Magnet would go by like that, and it's laying right there. Because I've tested this, and if it has sort of a shape like that, and if I put it right next to the magnet about like that, it triggers quite routinely. And then whatever I need to do, one of these things is made for adjustment. I think it's the lower one, I'm not sure now, but in any case, I could pivot this a little bit and get a little more adjustment to dial that in and then tighten that up. And I think this will be a tight enough fit. I'll just put some little glue right here to hold it at the top. That's all I'm going to need to do. I think it'll be a good fit. So I got to design that little part and print it after I get the wheel on, and then I can reassemble this, and then I can begin the wiring. So yeah, okay, a few things. Put the wheel on, make a new bracket, drill the holes, maybe print a new deck plate, and then start your wiring. But really, look, what? It's only 4 and 4 is 8. 8 wires. 8 wires, and they don't go really anywhere nasty. The only really tricky ones are the ones that go to the motor, because I'm going to have to put a junction on those so that I can get the motor signal to these yellow wires as well. I'm going to have to tie the yellow wires into the motor wires at the motor. That's the only weird thing that I have. But I'm going to put a lot of loop in this, and I'm thinking I may just splice them further back. What I'm thinking about doing is, this is the motor wire, okay, and there's the wire. It's going to get soldered to the little motor thing that goes on the brush. What I'm thinking is I might cut the insulation here and just push it back, so I end up with a spot where there's bare wire with insulation. And then what I'll do is just take that extra wire that I need and sort of just wrap it around and just solder that up and put a nice big sleeve over it so it's protected. I don't really want to cut this wire anymore, but if I wrap this around it and take that signal off, I think that's going to work. I'm going to get the current coming off the motor, and I don't want to interrupt that wire any more than I have to. So I'm going to have one joint for the motor to the brushes, and it's right here. You socket it in, and we've been doing that for years in all the engines, socket them and plugging them in. I don't know what that is. So I know that'll work. That works well. These are pretty understood things. Okay, I'm going to run now. I'm getting a little hungry. Margaret had a visit to the doc. They did a echocardiogram. Very interesting. I have seen echo before, but not like this. Here we were imaging the heart while it's in her chest, of course, beating, and you could see the valve, flapping. And then he puts color on top to measure speed and pressure, and you could then see through color pressure and the direction the blood was flowing, and did all 4 chambers and all the valves and capacities, muscles size, chamber size, all this stuff. It was really remarkable. It took about 45 minutes. It was all with a non-touch, about the size of this box, and he put grease on it, and then he puts it on her chest and moves it around, and then he finds the heart and the valve, and he can bring that image in. It was just pretty remarkable. Anyway, it makes for a trying day, though. You have to drive into the hospital, and then you do it, and then you drive back, and you're all fried. So we're a little late getting going today, but tender's wired. I'm so happy about that. Tender's wired, speakers in, a speaker is in. I'm not sure it's going to be the speaker, but it's one that I bought, and I have it. I will do some more testing tomorrow probably on that, because I can power up the soundboard and just see what it sounds like. And I can trigger the Chuff manually. That way I can see what that's all about. And then hopefully we'll get the engine wired tomorrow. I don't know what today is. I don't know. Is it Wednesday or Thursday? At any rate, that's it. That's where I'm at. Talk to you guys later. This is how I would wire the engine. I had come up with this scheme, did another diagram of the whole engine wired. So I kind of knew what I was going to have to do. I parsed it, so I knew what these 2 wires did. These 2 wires did. Okay, that's one connector. And then the other 2 were pretty straightforward. And you know what the connectors are going to be. You want the females here so nobody can touch anything. If that's hot, they won't get electric power coming out. You want that. So I think we're going to be just fine. I think we're going to be just fine. Always things that pop up. Okay, tomorrow's another day. We'll talk to you. Bye.